Hi everyone, my name is Nader Mortazavi. I'm a solution engineer at Noble 9, and today I have a couple of experts in machine learning that we're going to discuss how machine learning and SLO work together. I'll just turn it to you, Uwit, to introduce yourself, and then I have a question for you.
Okay, so hi Nader, my name is Vitya Kotron. I'm CTO and Principal Data Scientist at F33 company.
And I'm Mariana Kiska. I'm data scientist at F33 company.
Well, thank you both for being here today. So today we're trying to understand how machine learning principles and SLO connect. So my question to you is, Wid, why do you think the machine learning systems requires SLOs?
Yeah, so to answer this question, I will show you a few slides so that we understand each other perfectly. So first, machine learning models are very complex by definition. They depend on many things, and the most important are business, data, mathematics, and engineering. So to have all this together managed, you need to special approach for that. So machine learning models are mathematics. This means you live in two worlds. So business thinks of business performance measures, business success measures, business goals. But when you build a model, you go down to a very formal formulas, and you have to monitor both sides. Second, machine learning models in fact don't exist. What you build automated pipelines that generate instances. Very concrete machine learning models. Very concrete instances generating during the time and on different data sets. The next challenge is when you build a model that forecasts or predicts anything, to calculate the performance, you really need to take into account a very unnatural for human being delays. So when you forecast demand in 2 days ahead or churn decision in 6 months ahead, only after this time you can say if the model was correct or wrong. The next thing is that machine learning models depends on data that is changing in time, and this means that models built today in next future will be of lower performance. So you have to understand this, and you have to find the moments where the model's performance deteriorates at the level you are not accepting. So having this put together, I find SLOs important for machine learning because you can monitor all aspects of machine learning models in parallel and make this actionable. Okay, so this is make this actionable. So let's get back to this one. So you monitor machine learning models at all the aspects and make this actionable. This is depicted on the slide. So you calculate the raw measures, put them into a storage, and then there is a question how to make automated closed loop or feedback loop that helps you manage the models at scale.
Thank you so much, Wid, for going over those principles. They sound very interesting. And now I want to bring up Maria, who is a data scientist at 1433, to go over a taxi rides use case for us. To you, Maria.
Yeah, thank you, Nader. I will go through the taxi rides case, as Nader said. And we all know that today's taxi companies have mobile apps which can tell us the estimation of the taxi ride, because it's crucial for customers to know when they will be, if they will be on time or not, and how much the taxi ride should take. So we can have multiple SLOs and their types. And first one is business SLOs, and it tells us how big is the error in minutes between time travel estimation and the real value. And the other one is SLO, and it tells us how much the error exceeds 1 standard deviation, 2 and 3 standard deviations. And in the view of high-level architecture, it's like we have a Noble 9 product which is monitoring we have a target and scores values, which comes from, in our case, from BigQuery. Then it goes to the Noble 9 product, which is meant for monitoring it. And the Noble 9 can trigger retraining if it's time for it, when the data, for example, deteriorates. And when the model is being retrained, it can be reused for serving, redeployed for serving, and then the path continues. And I will go now to the live demo and show you the product in real use. So here I am in the Noble 9 dashboard, and we can see here our defined SLOs. And the first thing I did here in the Noble 9 product was integration with BigQuery. We can have a bunch of different data sources connected, and I chose BigQuery one. And now I will go to some demo part for this for our taxi use case. Here we can see a dashboard for error deviation. We can see that most of times the error deviation was about 1 or 2 times standard deviation, and here it goes smooth. This value don't go up too much, but then we can see that the standard deviation from the average was getting worse, and it was getting worse a lot of times. So it can indicate that the input data has changed. For example, there was there were roadworks in the city center, and it had impact on the duration of taxi rides. We can see in the wider view that this metric dropped here, and this is the time when we alarmed for the model retraining, and then we had to wait for the model to be retrained. And here is the point in time that we stopped retraining the model and we redeployed it, and we can see that the metric was on the same threshold for some time, and it means that it stopped decreasing. So the model was started working good once again. And in the wider perspective, we see that the metrics got back to their standard level. And on the other hand, we have this business metric, which shows us that the model wasn't wrong many times. The error wasn't above 2 minutes. The most of the time the error was lower than 2 minutes. Yeah, we can see it here, and there we have this data change, and we can see that error started giving more. The error that the model was giving was larger, and we can see it also here, that the threshold that this value was was decreasing, but it didn't reach the threshold that we set. So from the business point of view, nothing bad happened. And we managed to detect the change and react quickly for this change. And the metric is good all the time. And for this, like the second, yeah, I think I can stop there. Now I can show you how to make an alert. So we can go to integrations and add an alert method. And here I have created an alert for retraining and used a webhook. I will show you now. We can also get a bunch of integrations, and I have chosen webhook here. And when we have an alert method, we can add the alert policy, and it's done in this tab. We can click here and define the policy and add a name. And here we can here we can select our webhook created earlier.
Well, thank you, Maria. That was very, very wonderful. So what you showed us here was the way that your team is using Noble9's platform to monitor the way that your taxis are staying true to the machine learning model that is defined for them. And what you showed is that you have both business and technology metrics around those two use cases. And once any of those thresholds on the reliability burn down goes below and you consume your error budget, you're automatically using webhook to retrain your model. So we're really working towards automations and minimizing the actual manual work around this. And that's where Noble9 platform comes in very useful for the machine learning products.
I wanted to say that the common pattern we observe when we are monitoring and maintaining models is that business alerts are not always reached if we have good alerts on technical measures, as it was shown in the demo. We believe and we see a great benefit of using Noble9, which by automating our maintenance work can help us manage many models in parallel.
Well, thank you both for your time today. And I want to highlight that Noble9 is helping companies such as 1433 and the ones that are using machine learning in their platforms to bridge the gap in between monitoring your actual data model and automatically retraining it when it's needed. Noble9 platform is currently available, and you can go to noble9.com/hydrogen and start a new trial and try the product for yourself. Let's SLO.